Okay, this video goes with the guided notes for angle, side angle, and the hypotenuse leg triangle congruence theorems, which is section 4.4. Okay, so let's take a look. The angle, side angle congruence theorem, well, let's review for a second here. So far, we've talked about side congruence. If three sides are congruent between two triangles, then all the 6 parts of those triangles are congruent, which means all the angles are congruent. We also talked about side angle side. If two sides and the included angle are congruent between two triangles, then all 6 parts of those triangles are congruent. The included angle is the angle that kind of hinges the two sides together. We're moving on today to talk about angle, side, and angle, side angle, and hypotenuse leg. Which is side angle. But side angle only works for right triangles, and we're going to see that that's actually the hypotenuse and the leg of a right triangle. So let's look. So here we have angle M congruent to angle S. We have angle N congruent to angle T, and the included side that connects those two angles together, MN, is congruent to ST. So this gives us an angle with an angle, gives us a side with a side, and the other angle with the other angle, gives us an angle, side angle pattern. So if this angle, side angle pattern exists between these two triangles, then the triangles are congruent, and that means that all the angles that correspond are congruent, and also that the other sides are congruent. The other theorem we have is angle, side. So as if you're going around the triangle, let's see, angle U is congruent to angle X, angle V is congruent to angle Y, and then the next side, VW, is congruent to YZ. So as we go around the triangle, we see angle, side, angle, side. So an angle, skip a side, an angle, and then the next side is the angle, side pattern. If two triangles are congruent by angle, side, then all 6 parts of those triangles are congruent. Angle W is going to be congruent to angle Z because those are corresponding parts. Side UW is also going to be congruent to side XZ because those are corresponding parts of congruent triangles. And then side UV is going to be congruent to side XY. So let's look at how they name these. MLN. So M is the single marked angle. L has no marks on it at all. And N is the double marked angle. So this corresponding order needs to be on the other side also. So angle S is the single marked angle. R is the angle that has no marks. And T then is the angle that has 2 marks, which is congruent to N. So notice that their corresponding positions need to be the same. If I wanted to start this one with L, and say go M and then N on the other side, then I would have to do R. So I went from L to M, so I have to go from R to S, and then to T. And that would be how I could name the congruence correctly if I decided to start with a different order of vertices. Same thing with UVW and XYZ. If I wanted to name UVW differently, let's say WUV, then the other side would have to be ZXY. so that we would keep the corresponding vertices in the same relative positions with the ones on the other side that match. So look at number 1. We want to use angle side angle. What additional information is needed? So we're looking for two sides in the included angle. Two angles in the included side. So we've got angle A matched with D. We've got side BA matched with ED. What's missing is this angle here at E and this angle here at B that need to be congruent to each other to have the angle side angle pattern. So what's missing is that the measure of angle B is equal to the measure of angle E, or in other words, angle B congruent to angle E. If we had that information, we would have angle side angle, angle side angle. And we could say the two triangles were congruent because of angle side angle. Now let me erase this, and we're going to do number 2. So let's see. So for number 2, it says, what additional information is needed to show that triangle ABC is congruent to DEF by angle side? Now, angle side is like an angle, skip a side, an angle, and then the next side. So let's see. So angle side, if we had C, that would give it an angle, and then A would be the angle, and then BA would be the side. So angle C would have to be congruent to angle F. Two corresponding marks here. So if C was congruent to F, if angle C was congruent to angle F, then we would have angle side, and the two triangles would be congruent. Now, in a right triangle, the two right angles are going to be congruent to each other. They're showing us that one of the legs is congruent to the other leg of the other triangle, and that the hypotenuse is congruent to the other triangle's hypotenuse. So this actually sets up an SSA pattern, which only works for right triangles. So to avoid mixing up SSA in regular triangles, we narrow this down to only right triangles by talking about the hypotenuse and the leg. So the hypotenuse is actually the longest side of the triangle, which is one of the S's, and the leg is one of the other sides of the triangle that actually makes up the right angle. And since the angle is right in both triangles, we have two right triangles, and a pattern that lets us know that they are congruent is if we can show that the two hypotenuses are congruent to each other and that the two legs that correspond are congruent to each other. And we call that hypotenuse leg. So if MNL is congruent to PQR, then we could also say that triangle MLN is congruent to triangle PRQ, as long as I keep the same relative letters in the same corresponding positions. I have different ways of naming the congruence. So another way we have of proving triangles congruent is hypotenuse leg. Another thing you might see sometimes is one we call leg. So let's look at two right triangles, and let's mark the two legs as congruent, and we have two right triangles. So some geometries will call this leg congruence in right triangles, which is really the same thing as side angle side, where the angle is the right angle between those. So side angle side is the same thing as leg-leg in a right triangle. The only difference is in the leg-leg version, the angle is right, which lets us talk about leg-leg instead of side angle side. So you may run across leg-leg if you look at other geometry videos or look at other geometry books, or talk to somebody else that's taken a different geometry than we have. It's the same thing as our side angle side. Okay, what additional information is needed to show that LMN is congruent to PQR by HL? So we're looking for hypotenuse leg. So let's see what we got here. So LN, which is the hypotenuse of one triangle, is 9. So to get the other H part of the pattern, PR would also have to be 9. And if QR is equal to 5, then MN would have to be equal to 5. And that would give us the leg part of the pattern. So this would give us hypotenuse leg. So in a right triangle, hypotenuse leg can prove that the two triangles are congruent to each other. So we would need to have that PR distance is equal to 9, and also that MN distance is equal to 5 to be able to prove HL, linking those two triangles together and making those congruent. Now let's look at these examples here, or these other ones to work out. So here we have an angle side angle pattern, angle side angle pattern. So these two triangles are congruent by angle side angle, and we want to correctly name the congruent statement. So let's say I'm going to go L, let's start with one mark, K to L to J. So if I want to go triangle K, L, J, and have it be congruent to this triangle, I need to do the same order. So I start at single marked to double marked to no marked. So single marked to double marked to no mark, NOM would be a correct way of naming that congruence relationship. Let's look at number 2. Number 2, this side is reflexive. It's shared by both triangles. It's like a same side idea. And so we have an angle, a side, and an angle, angle, side, angle. We've got a matching angle side angle pattern between these two. These two triangles are congruent by angle side angle. If I wanted to name the triangle, say, A to B to C, and have it in a correct congruence relationship with the other triangle, I went from A to B, from the single marked angle to the no marked angle. So I want to go from A to D on the other side, and then to C. So triangle ABC is congruent to triangle ADC, would be one correct way to name the congruence. Let's look at number 3. Here we have P is congruent to M, that gives us an angle. We've got Q congruent to N, that gives us an angle. And we have QR congruent to NM, that gives us a side. Notice what we have, though, is here we have an angle side pattern. But what we have here is an angle side angle pattern. These two triangles cannot be congruent. So we say not enough info. So because the two patterns don't match, we can't use angle side angle or angle side to relate those triangles together. And if we look, the triangles really don't look like they're congruent anyway. Let's look at number 4. J matches with Q, K matches with R, and PR matches with KL. So if we look at these triangles, we have an AAS pattern around that way. We have an AAS pattern around this way. These two triangles are going to be congruent, or they are congruent, because of AAS. Let's say I wanted to go JKL, triangle JKL, then would have to be named as congruent. Notice I went from J to K, I went from 1 to 2. I got to go from Q to R, and then to P to get the letters in the right order, or the vertices in the right order. Let's look at the next one. Okay, here these two angles are congruent because they're vertical angles. This side is congruent to this side. That gives us an S. This side is congruent to this side. That gives us another S. And this angle is congruent to the other angle. That gives us an A. So we have an SSA pattern. This only works for right triangles. These two triangles are labeled as congruent, but all these angles aren't labeled as congruent, which would cause these to have to be right angles. And there's nothing about these two being perpendicular or this being a right angle. So we don't know for sure that we have right triangles. If we did, it would be hypotenuse leg, but we can't say one way or another. So this one cannot be determined. Or not enough info. Let's look at number 6. So number 6, we've got that AC is congruent to ZY. We have a right angle here. It's congruent to the other right angle. And here we have XZ, which is congruent to AB. So this is an SSA pattern, but since these are right angles, we actually think of this as being hypotenuse leg. So this is the hypotenuse leg pattern. Because we have right triangles, we have hypotenuse leg, and the two triangles are congruent. So if I went A to C to B, on the left, I would have to go from A to C. I would have to go from X. That doesn't look right. Let me see here. I'm going along the leg. I have to go from Z to Y to X. Z to Y to X. So Z goes with A. C goes with Y. Those are the two right angles that are congruent. And B goes with X. And this gives us hypotenuse leg. Okay, so the rest of these are for practice. And in addition, for this packet, you have the 4 reteach and also the 4 mathematical literacy pages.